In this exercise, let's study classes in Kotlin language. Let's create a project named Kotlin Classes. There are some similarities and differences between Kotlin and Java classes. So let's first create a Kotlin class representing a student. So here, for organization purpose, since the student class could be just any generic idea, so according to model view controller software architecture, the definition of students class could be a model. So let me create a model package there. So package named model. So within model package, let me create the Kotlin class named student, and then that is a class. So when you define a class, so far it's very similar to Java. One critical difference in terms of syntax is that Kotlin has a primary constructor, only one primary, and then many secondary constructor. The primary constructor is declared inside the parentheses after the class name. So here you declare a primary constructor. So primary constructor is simply to assign the values as its object is created. Like for example, you can create an object of student like a val or a value in S1, and then in Java case we use keyword new, but Kotlin we do not use any new operator at all. And then here, suppose I want to give a name and GPA and the like, then an object of a student is created, and then the object reference is stored in S1. So without the keyword new, this is very similar to Java in terms of syntax. And then in the primary constructor is simply receive the arguments and then store that into member variables. So if that is the case, then you can define a primary constructor within the parentheses. Then just declare a variable, like a variable named the name of a string type, the variable named the GPA of a double type. Then I have defined the primary constructor already. So this is inside the parenthesis. What you give is a primary constructor. But if you need to do more than simple assignment, then after the assignment is done, you can give some more additional statement if you need to do. For example, I want to check whether the name given as string is empty or just blank only. So if additional processing is required, then there is a designated block called the init block. So give a init block inside the curly brace. So init block will be called after the primary constructor. In the primary constructor, you don't give any explicit code for that. Just define within parentheses. Then when object is created, those values are provided, and then that's simply assigned. John is assigned into name. 2.5 is assigned into GPA. That's it. But if you wanted to do more processing in addition to simple assignment, you need to define init block. In init block, for example, I can check whether the name is empty or not. If name is null or empty, or if name is null or blank. It could be just empty, it could be just blanks only. Then what I want to do is I want to assign name an initial value of no name, something like that. At this moment, if you remember, we tried to avoid the hard-coded string in the Android project, but this student class is simple Kotlin class. It's not Android activity. So for this student class, the string resources, those mechanisms are not available. So if you want to have those ones some similar to avoiding hard-coded strings, then you could define a constant in one place and then use that place for later translations or whatever. Something like above the class definition, you can define some constants, like const val ini no name, something like that, and then no name. Just define constant and then give a constant here. Then instead of looking for the body of the program code, just look up one place to find all those hard-coded strings. And then if you want to check GPA, if it's in range or not. So if GPA is negative or GPA is greater than 4.0, then I want to set GPA is 0 as an initial value. So this init is called after the simple primary constructor. And then if you want to add the members outside of the primary constructors, you can do that, such that just define variable age of int type, and then you can give initial value for that. So this is a additional member added. So here, in addition to name and GPA, now age is added. In Kotlin, when you declare a member, the default getter and setters are automatically provided. So what I mean by that is for name, get name, set name is provided. So for outside the class student, you can simply use a dot name or dot GPA. So for age, as we add a new member, the get age and the set age, getter setters are provided. But if you want to override the default setter and getter, it's simply assignment. Now you can define setter and getter just below the member declaration. Now use a keyword set for a setter definition, and then whatever value, variable name, which is parameter name, is provided, then what you want to do with the value. So you could do something like if age is negative, so we want to set 0. So something like if value is negative, then we want to set age as 0, something like that. Then you may think that, so I want to set age if negative 0, else just current value, use that. Here is one of the common mistake as a beginner of a Kotlin. Whenever you use a variable, member variable name, then automatically getter is called, not the variable itself is directly accessed. So especially when you define setters and the getters of a member variable, don't forget that you do not use the member name directly. If you use it like age, then get age is called. So that's not good. So we have a special keyword called field. So within setter or getter of the member variable, the keyword field is to have access to the member age directly without going through getter or setter. So similarly, you can do get function for age, then it returns int type. Then here you can return field, not age. If you give age here, then you have recursive call. This is not just having access to a member variable age directly, but it's the same as a get age. So within get, you call get age again, getter again. So you have a recursive call without ending. So eventually it will be out of memory and the program will crash. So remember that keyword, the field should be used. What it says in Android Studio now is hint is the redundant getter, because the default getter provided is exactly like that. So by explicitly typing this one is redundant, what it says is do not do that unless you do more than that. So anyway, age is provided, and then to trace the execution, let's give some message there. So inside init, we want to print out some message on the console. In Android Studio, there is no such console, but we can use some other feature to display some message. So that is a log class is provided. So Android utility log class is there. So Android utility log is there. And then we have a I function or D function or a few of those. D is intended for debugging, I is for information, but whichever one you use, we don't actually care. But here, first parameter is some string tag. So you can just look for any message by the tag. So let's define a tag on the top here that saying const val tag is a student, something like that. Then tag, and then you can give any message as a string there. Then this message will be on log cat window. If you look up the down in the Android Studio, there is a log cat tab. On this tab, whatever message you put on the log, well, that will be displayed. But there are huge messages are there. You can filter by the tag easily. So let's say init function is called, and then for this init function, the name value of this current object is there. So let's give those one. And at this moment, let's do log I, same tag, say setter age setter is called, and then the name is the current member variable name. Then here log.I before return, log.I giving tag, and then message is age getter is called for this name. So as you can see, as I add one more line of a getter, the warning message disappears because that's more than a default getter. So now let's test this part. Is that on main, let's create student object, student John alt return. So the student class is imported, GPA and like. Then on logcat and show only selected applications. If I click, then edit filter configuration, and then you can give any filter. So filter we give is a student is the tag we gave, and then you can give some filter name, student filter or whatever, you can give that. And then if I say OK, then the messages from Android system which has a student filter is there, and that one will be displayed only. So let's run the program and then see some log messages. It's being built. Of course, you choose no filter, then you see lots of messages coming from Android system. Those are the system messages. There are too many information there, so let's just filter out this one. So what you get is init and John was there. So init block is called with the name John, and then no getter or setter of age is called because age is added member, and that is not used. In this example, I've used John and 3.9, which is a primary constructor only. Now we can define many additional constructors. So secondary constructor, in addition to primary, you can define as many secondary constructors as you like. And the secondary constructor has a special keyword to define that. If you remember C++ or Java, we use class name to define constructor, but in Kotlin, we never do that. The primary constructor we define at the class declaration header, and the secondary constructors you use a keyword constructor, and then you can define parameters. So here, even if you use a keyword constructor, this is like a function. So in this function, what do you want to receive? So for example, when I declare, when I create an object of a student, I want to provide name, GPA, and then age, something like that. So here, what you want to do is like a function parameters. So name, string, then GPA, double, and age, int. That's what you want to get as a parameter list. Then when you define secondary constructor, you need to call, as the error message says, a primary constructor call is expected. So you need to call primary constructor for the secondary one. So here you need to give a colon and then call primary constructor. So primary constructor to call, you use the keyword this parenthesis. Then a primary constructor requires two values, a name and GPA. So the name is whatever is given for the secondary constructor. So name is forwarded, GPA is forwarded. Then age is a third member we defined and added here. So you can do something with the third member. So in this third member, this.age means a member variable, and then age is the parameter specified. That's what you want to do. So at this moment, let's give a log message I with a tag that secondary constructor is called, and then name for this one is name, the like. Also, we can give age there. So in the main program, let's define, create another object. Now let's give name as Bill. Then let's give age with that. Then let's run the program again. Then we should see some other message there. So the first line was from the previous run. So second line is the first run. So here John is created, and then second one Bill is created. When Bill was created, the second constructor is called. Then when you do set, so we do setting here, So as you can see, setter is called. So even if we use syntax this.age, it does not mean we access to the member named age directly to the variable, but we go through setter. As you can see, setter message there. So the execution order is after the primary constructor, init block is called, and then if you use a second constructor, the second constructor forwards some of the value to the primary constructor. So primary constructor is called the first, then this is the message init there. Then init is called, then whatever you do within secondary construct is executed. And then a secondary constructor, you can give as many as you like if the parameter list is different, like it's a function overloading. So if you have a different list of parameters, then you can give as many secondary constructors as you like.